All right, so this is the start of Unit 13, and then a little bit of 14 at the end. 13.1 is trig functions and right triangles. A lot of this you did last year in geometry. And then there's the homework 15, 18, 21, 22, 26, 29, 30, 32, and 37. There's a lot of problems here. For the most part, we have 9. They just cover 13.1 it just covers a lot of the basics, so they should go very quick. But opening up, so I learned I can find the values of trigonometric functions for acute angles, side lengths, and angle measures for right triangles. So trigonometry, like you did last year, it's kind of the study of relationships between the angles and sides of right triangles, and they're used a lot in construction, engineering. If there's one thing in math that you're going to be using, it's trig. If you're going on to heavy amounts of math for work. But now a couple things right off the bat. So we have sine, cosine, tangent. These you should know. You kind of know that whole so, ka, and toa abbreviation, right? And then the other three that I don't think you talked about last year that we have now is cosecant, secant, and cotangent. What cosecant is, it's basically the reciprocal of so. So basically it's kind of like cosecant, and then it's hypotenuse over opposite. It's just flipped instead of having sine. All right. So you can almost think of this as, I don't want to use this first one, but this is like, right, instead of having cosecant, or instead of sine, it's cosecant, and then hypotenuse, and then opposite. So if you wanted to put a C here, you could. Then you have secant, which is the opposite of ca, so you have the HA. And then you have cotangent, which is AO. All right. I don't really want to put anything in front of there because I don't want to screw you up with what cosine and tangent are. This is what you know. Remember this, the sine, cosine, tangent. You just know that cosecant is hypotenuse over opposite, secant, hypotenuse over adjacent, and then cotangent is just opposite as well. So now the first example, what you could have is I might give you a triangle. The right triangle, you know for a fact, the hypotenuse is 13, and one of the legs is 12. And we need to find sine, and we'll put theta right there. So the angle we're going to look at is this angle right here. We have sine theta, cosine theta, and tangent theta. Theta is just basically saying that it's this angle right here. So what are the ratios, what are the fractions we're going to create? And then we have cosecant, secant, and cotangent as well. But first thing, we need to figure out what is this length right here. So for that, we're going to use a squared plus b squared equals c squared. So you get 12 squared plus b squared equals 13 squared. Remember, the hypotenuse always is the c. And so now we have 144 plus b squared equals 169. Subtract 144 on both sides. Get b squared equals 25, so b equals 5. So we know that the other leg is 5, and now we can start making a ratio. So sine is so opposite over hypotenuse, so 12 over 13. Cosine is ca, so adjacent over hypotenuse, 5 over 13. Toa, opposite over adjacent, 12 over 5. All right, and now it's just the flip of these ones, so then it's 13 over 12, 13 over 5, and 5 over 12. I like to use them like this. I like to set up this way just so that it can be very quick once I'm doing these three. And then you're just flipping right, because cosecant's the opposite of sine, so it's just 13 over 12. Secant's 13 over 5, and cotangent's 5 over 12. Right, so when we get to this reciprocal function, cosecant is just 1 over sine theta, that's why it flips. Secant is 1 over cosine theta, and cotangent is 1 over tan theta. All right, pretty straightforward. And then the other thing that's on here that you talked about last year was the special angles with 30, 60, 90s and 45, 45, 90s. 30, 60, 90s, basically it's the fact that you have this short leg, which equals x. All right, so the short leg just equals itself. The long leg equals the short leg times the square root of 3. All right, and then the hypotenuse equals the short leg times 2. That's what this diagram is telling you, is that this short leg, once we find this, you can find everything else. For 45, 45, 90, they're a little bit easier. You just have a leg, which equals itself. That's what the x's are. And then the hypotenuse equals the leg times the square root of 2. All right. So now if we flip the page, we're going to find the missing side lengths. Now, if you notice right off the bat, we have a 30, 60, 90 triangle. Right, the 60 gives that away. So I'm going to show you two ways that you can find that side right there. The first one is kind of the shortcut way. Now, this is only can be used for 30, 60, 90s, but you want to find the short leg. You have the hypotenuse, and we know that the hypotenuse equals the short leg times 2. And I know that the hypotenuse is 14, so 14 equals the short leg times 2, divided by 2, and the short leg equals 7. All right. The other way we would do this is the actual trigonometric way, and that's where we're looking at this angle right here, 60, and I have that hypotenuse. I'm looking for the adjacent, so I'm going to use and that's adjacent hypotenuse. I'm going to use cosine 60 equals x over 14. Cosine 60, when you plug that into your calculator, now make sure you're on degrees. So you hit mode and just make sure that you are in degrees. And then you hit cosine 60, and you get 0.5. So you have 0.5 equals x over 14, multiplied by 14 on both sides, and you get 7 equals x. Okay, very straightforward. I don't care which one you use. For this example, notice this one's a 45-45, and you have the leg equals 10, and we know that the hypotenuse is the square root of 2 times the leg, so the hypotenuse equals 10 times the square root of 2, which equals roughly 14.14. If you were going to do this the other way, the more trig way, this is the angle I'm going to reference, so 45, and I have the opposite. I'm looking for the hypotenuse. That tells me that sine is what I'm going to use, and it's 10 over x. This sine 45 is roughly 0.7071 equals 10 over x multiplied by x on both sides, and you have x times 0.7071 equals 10 divided by 0.7071 on both sides, and x equals 14.14. Right, you should get the same answer. Now, if you're not given a 45-45 or a 30-60, you have to use this way then. The last part now is inverse of trigs, and that's on your calculator. Well, all these buttons are on your calculator. Right, you got sine, cosine, tangent, and then if you hit the second key, you can get the inverses of them. But you use the inverse to find missing angles. All right, so use the inverse to find the missing angles. So we're here, so we're looking for this one right here. In reference to this angle, I have the adjacent and I have the hypotenuse. So if I'm looking at SO, CA, or TOA, right, adjacent, hypotenuse, is CA, so I'm going to be using the inverse of cosine. I'm looking for an angle, so the inverse of cosine. And then that's where you make the ratio adjacent over hypotenuse. Plug that into your calculator. So you hit second cosine 15 divided by 17, close the parentheses, and you should get 28.1. So that's what this angle is. So it's kind of nice because you can figure out all the different angles, you can figure out whatever sides you want. And the last thing I want to talk about is in the case of 17. So this is where you kind of have to be a little creative. It says if tan A equals 8 over 15, what is cosine A? To solve this problem, what I'm going to do is I'm actually going to draw a right triangle. Right there, I'm just going to choose that this is angle A, right there. And then it says tan equals 8 over 15, but tan is TOA, right? So it's opposite over adjacent. So my opposite is 8, my adjacent is 15. Now if I need to go find what is my hypotenuse. This is where I want to use Pythagorean theorem. When you do that, you get that the hypotenuse is 17. All right, and then what is cosine A? Well, cosine A then would be adjacent over hypotenuse. So it's 15 over 17. All right, so that's kind of how you do the problem like that. All the other ones you kind of have everything you need. So that is 13.1.